Hey there, in our last video, we saw the college board set some nasty traps where pure algebra was the fastest way out. But today is pure unrelenting Desmos domination. Welcome back to Bhargav Academy. We are tackling questions 26 through 30 of our hard nonlinear series, and I am going to show you how the built-in graphing calculator completely breaks these problems. If you try to use the quadratic formula on question 27, you will be wasting 5 minutes of your exam. I am going to show you how to bypass all of it and get the answer in 10 seconds. Let's lock in and speedrun. Minus 3x square plus 24x plus c equal to 0. That's question, okay. Question number 26. In the given equation, c is a constant. The equation has exactly one solution. If you see one solution, most probably Desmos is the way. So what is the value of c? Let's go to Desmos because we have seen one solution. Let us type this one down. 3x square plus 24x plus c. So add a slider as always. Take this from 100 minus 100 to 100. So what is the point? The equation has exactly one solution. So this graph should touch the x-axis at exactly one point. Let us see where it is touching. So I think it is touching there. Let me zoom in. No. I think this is where it is touching. Yes. It's touching. So C, what is the value of C? C is minus 48. You can see it from here. So yes, that is the answer. Desmos is clear winner here. So whenever you see exactly one solution, go for Desmos. Let's go to the next problem. The solutions to x square plus 4x plus 1 equal to 0. R and S are the solutions. So R and S are solutions for first equation, and R is less than S. Okay. So if the graph is like this, R should be here and S should be here because R is less than S. Now, what about the next one? The solutions to this are T and U. So, if I plot this second equation over here, let us say it comes out to be like this. So, if one solution is T, it should be here, and another solution is U, it should be here, and it is because T is less than U. So, these are the location placement of the roots. R and S should be like this. R and S should be like this, and T and U should be like this. T is less than U. Now he is asking you the solutions to this new equation, which is the solutions to this new equation, x square plus 14x plus c equal to 0. R plus T and S plus U are the solutions to this new equation. So R plus T are the solutions, is one solution of this quadratic, and S plus U is the another solution of this quadratic. And then he's asking us to find the value of C. Where is C? C is sitting here. Now let's go to Desmos. Let me take this away so that past memories don't haunt us. Okay, let me substitute the first equation here. Let me type it down for you. X square plus 4x plus 1 should be equal to, okay, let me type till there only and see what is coming out to be. So what do I get here? R is coming out to be minus 3.73205. So let me type that here. R is equal to what is it? Minus 3.73205. Minus 3.73205. Okay, so whenever you type R equal to something in Desmos, it by default consider it to be radius of a circle. So we have to change the variables here. Instead of R as TU, let me take them as A, B, C and D So instead of r plus t and s plus u, I should be checking for a plus c and b plus d. So what did I do here? Instead of r, I have considered that to be the variable a. Instead of s, I have considered b. Instead of t, I have considered c. Instead of u, I have considered d. So that's what I have done. So here instead of r, I will substitute this as small a. Now, what is the value of this other root b? That comes out to be minus 0.26795. b is equal to minus 0.26795. Minus 0.26795. So I have both the roots, the solutions, I have the value sitting here. Now let me switch this one off and go to the next equation. The next equation is x square plus 10x plus 13. X square plus 10x plus 13. What is the value of c? C is this point. C is equal to minus 8.4641 minus 8.4641. 8.4641. That is the value of c. What is the value of d here, which is this root that corresponds to this point? Minus 1.5359. Minus 1.5359. Let me first type it down so that doesn't run away from my memory. D is equal to, let me equate it now to d. Now what I should be finding out, a plus c and b plus d values I want. So I'll write down a plus d here. A plus d, where is d? Yes, that is the value. A plus d is here. And then b plus d, b plus d, where is it? Yes, b plus d is here. Now what I should be doing, he's asking me, so let me write down this equation for you. X square plus 14x plus c. He's asking me the roots of this particular equation are a plus c and b plus d, and he's asking me the value of c. I know that if I do product of this, product of the root should be equal to the constant. So ultimately I want to find the value of a plus c into b plus d. That will give me the value of this c. So let me do that. A plus d multiplied by, sorry, this is a plus, oh no, this is a plus c. I'm sorry, this is a plus c. A plus c into b plus d. Yeah, that's correct. A plus c into b plus d. Okay, here I have done 2 negative. That's the reason why things got messed up. Yes. So a plus c into b plus d comes out to be 22. So that is the answer of c, 22. If you try to do this in the algebraic way, it's going to take away all of your time. So don't do that. So what did we do here? We have substituted the first equation, x square plus, we have substituted the first equation, find out the values of its roots, and then substituted the second, typed the second equation, found out the roots, then we have done a plus c and b plus d, we have multiplied them, we have got the answer. Alright, so we'll go to the next problem. What is the sum of these solutions to the given equation? Let's type this equation in Desmos. Absolute value of x minus 12 plus 35 is equal to 51. So what do we have here? Okay, we have the two values, but it's not showing the solutions. So what do? Please don't panic. Bring this 51 to the LHS side and then we have the answer right before us. So we have two solutions. Minus 4 comma 0 is one solution. Another solution is 28 comma 0 is asking you the sum of the solutions. So is asking you to add these two. So 28 minus 4 is 24. That's your answer. Desmos is just lovely. Let's go to the next problem. So what do we have here? In the xy plane, a line with the equation 4y equal to c for some constant c intersects a parabola at exactly 1 point. Exactly 1 point. Go to Desmos. If the parabola has equation this, what is the value of c? Let's go to Desmos because we have seen exactly 1 point. Let's switch this off. Let me substitute 4y is equal to c. This is not looking good. Let me take this away so there is no c in our memory. 4y equal to c. Then what do we have here? Y is equal to minus 3x square plus 12x. Okay, second equation is looking good, but what is wrong with the first equation? If situation like this happens, try to equate c equal to 1 because it's not showing the slider. Now once again go from negative 100 to positive 100. So what is the question here? There are two lines. C has this is one line and this is the quadratic equation, and he's asking you both of them should meet exactly at 1 point. So let's make them meet at exactly 1 point by moving the value of c and see if it's happening or not. Yes, this is exactly at 1 point they're meeting. So what is the value of c? C comes out to be 48, right? Yes, c comes out to be 48. So that's the answer. So Desmos is again awesome. C equal to 48 is our answer. Done. Let's go to the last problem. Again, he has given you two equations. One is a linear equation, another one is non-linear. In the given system of equations, a is a positive constant, a is a positive constant. Okay. The system has exactly one distant real solution. Great. Go to Desmos, one distant real solution. Let me type this one. Let me erase the past memories. Y is equal to minus 2.5 and then we have y is equal to x square plus 10x plus a. Add slider. Take this from minus 100 to plus 100 just to be safe. What is the value of a? That's the question. Exactly one distinct solution. So both the graphs should touch each other at exactly 1 point. So let's make it happen by sliding C or A. I'm sorry, it should be A. Why am I not seeing anything here? Okay. No. Take to the other side. See. No, it is still not touching. It's touching at 2 points. So 42. Okay, where should we stop? Let me be careful here. Let me slowly change it to 22. No. 21. No. 23. Okay, we're getting close. Make it 22.5. Okay, that looks like it. Let me zoom in and check. Yes, 22.5 is the answer. So A value is 22.5. A is 22.5. So in all of these problems, what we have seen is whenever you see one distant real solution exactly 1 point, Desmos clearly wins. So this is for today's video and. Today you have learned something new. What is it? And that is exactly how you solve in Desmos if you have problems like this. And that is exactly why you have to master this calculator for the digital SAT. When you use the slider tools correctly, it literally feels like cheating. Even if it takes us few extra minutes to break down these concepts together today, the time you are going to save on test day using these exact visual hacks will be massive. But listen, watching me drag a slider on a screen won't build your muscle memory. You have to do it yourself. Go to the pinned comment right now, download the blank PDF for these 5 problems and open up Desmos on your own device. Try to replicate every single shortcut I just showed you and use my class notes to check your logic. Which of these 5 Desmos hacks was your favorite? Drop it in the comments below. Make sure to hit subscribe so you don't miss our next masterclass, and keep practicing. I will see you in the next video. Bye bye.